Hello, today we're going to find the equation of a tangent line to a polynomial function. So we're just going to start by considering the function f of x equals 2x cubed plus 3x plus 1. And we want to find the equation of the line tangent at the point x equals 4. So in other words, assume this is my function on a set of axes. Here's the value at 4. I want the equation of this line that is tangent to that curve. So, to find the equation of a line, I need two things. I need the rate, otherwise known as the slope, and I need the start. Okay? So, what we're going to do is first find the rate or the slope. Well, the rate of change at this point of this equation is equivalent to the derivative of this function at that point. So the first thing I'm going to do is find the derivative. So the derivative of this function is 6x squared plus 3. 3 times 2 is 6, drop the exponent. 1 times 3 is 3, drop the exponent. Now to find the derivative at 4, I simply substitute in 4. 16 times 6 plus 3 happens to be 99. So now I have the rate of change. So I'm going to use Teague's favorite method of finding the equation of a line, which is point slope. So in order to do that, I need y minus a y value equals the slope, or the rate of change, times x minus the x value. I know the x value. I know the rate of change. I need the y value. To find that y value, I simply substitute in 4 into my function and find that corresponding y value. 2 times 4 cubed plus 3 times 4 plus 1. And then I end up getting 141. Now I can plug in. I'm going to do y minus my y value equals my slope, or rate of change, times x minus my x value. When I distribute that, I get 99x minus 396 plus 141, and I end up with 99x minus 255. This would be the equation of the line tangent to this graph at this point. Then some of you might think I'm crazy, so we're going to graph it and see what happens. On my graphing calculator, I'm going to go to my y equals, and I'm going to type in my original function, 2x to the third plus 3x plus 1. Oops, and I have an extra 3. So I have to back up, and I'm going to delete a 3. Okay, so, I didn't have an extra 3. I got to insert plus 3x. I forgot a plus. So 2x to the third plus 3x plus 1. I am then going to enter in what I deem to be the equation of the tangent line. I'm going to make that a bolder line, just so that it's very clear. Ooh, actually, I'm going to make this one the normal one. I'll make the other one the bold line, the original function. Okay, up, and I'll make that the bold line. So then what I need to do is I need to find an appropriate window. Luckily for you, I pre-found a window that I deemed was nice. And I went by ones. From here, I went from negative 10, negative 10, negative 10, and I went to 300, and I went by 0, because I didn't want to have any scale. So then when I hit graph, that is my original function, my cubic. It goes down on the left side, and there's my tangent line at x equals 4. So then you can see here at x equals 4-ish, if I go up to the line, that is tangent at x equals 1, 2, 3, 4. And this is a cubic. Whoops, sorry, can't draw that. This is a cubic, so it goes down on this side as well, just so you know. So again, that's the equation of the tangent line. Let's try another example. let's do the equation y equals x cubed minus 25x plus 3, and I want the equation of the tangent line at x equals 5. Okay? So what I would like you to do is find the equation of the tangent line on your own, and as you get stuck, we'll come back together and see where you're stuck. All right, first thing I'm going to do is find the slope. So I need to find the derivative of this function. 3x squared minus 25 is the derivative. To find the derivative at this point, at the point 5, I simply substitute in 5. 3 times 5 squared minus 25. 5 squared is 25, times 3 is 75. 75 minus 25 is 50. Now, in order to use my Teeb's famous formula, I need to find the y value. To find the y value, I simply plug in my x at that point, and then I get 5 cubed is 125, minus 50, plus 3 is 78. Using this formula, I plug in my values. Y minus the y value equals the slope, or the slope at that instant, times x minus 5. Then I do a little manipulation, 50x minus 250 plus 78. Do a little more manipulation of negative 250 plus 78, and I get the equation of my tangent line. Did you?